Welcome to section 1.2 algebraic expressions and models. The goals for today is that I can use algebraic expressions and I can simplify algebraic expressions by combining like terms. There's an exploration question. We're going to wait on this because I want to go over a few things first before we get to this. So we're going to come back to that. First, a few notes. A, numerical expression consists of numbers, operations, and grouping symbols. We are also looking at this right here. So if I have 2 to the 5th power, this is the same thing as saying 2 times 2 times 2 times 2 times 2. You'll notice I just wrote 2 5 times. So what this does is this right here, this whole thing, this 2 raised to the 5th power, all this put together is a power. So if you have 2 raised to the 5th power, that is a power. Now, we also can break it up by the different parts of this power. This right here, the 5, is the exponent. The 2 is called the base. So let's go ahead and take a look at how to do some problems involving powers. So on the first one, letter A, we want to evaluate the power negative 2 raised to the 4th power. Now, this is saying that we're going to take negative 2 times negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is 4, positive. Negative 2 times negative 2 is 4. And 4 times 4 is 16. So 16 is the answer for that. Now, letter B is a little tricky. A lot of people think, hey, this is the same problem as letter A. Well, it's not. The reason why it's not is because this is saying negative 1 times 2 to the 4th power. Well, and then if we do this, you'll have 2 times 2 times 2 times 2. We know that this is equal to 16. And then we have that negative 1. So negative 1 times 16 gives us negative 16. So you can see the difference. This one has parentheses, so everything inside the parentheses, even the negative sign, we're taking to the 4th power. This one, we only take the 2 to the 4th power and not the negative sign. On letter C, what we're going to do is we're going to take 2 to the 4th power, and you can see that it's just like this right here, just like the same problem that we just did right there. So we know the answer for this one will be negative 16 as well. Go ahead and try the U practices. If you have questions or you want to make sure that you're good, you can check with Mr. Rakowski, and he will tell you if you are right or if you are wrong, and then we can get it worked out. But these are for you to try and to make sure that you're on the right path. We have some other notes. Those notes include order of operations. Now, order of operations, I know you know, but the reason why I put this exploration on here is because this uses order of operations. And if you have to do order of operation in the right order to get the right answer. So let's look at order of operations. We know from previous courses that we use PEMDAS. Now, we know P is parentheses. We know we have E, which is exponents. But here's where a lot of people get messed up. For multiplication and division, those are actually the same. We want to group those two together. Same thing with addition and subtraction. So PEMDAS, parentheses, which could also include brackets or parentheses or possibly these curly brackets, those are all examples of parentheses. Exponents is when you have the power like we just did. Multiplication and division and addition and subtraction go in the same order. So these two go in the same order and these two go in the same order. The way that we determine which one goes first is by working from left to right. So let's go back to our exploration problem. So by PEMDAS, we have to do parentheses first. So this will be 6 divided by 2, and then 1 plus 2 is 3. Next, what we're going to do, instead of doing multiplication, which a lot of people might think, hey, we have to do multiplication first because PEMDAS is spelled PEMDAS, we have to do multiplication first. You don't want to do that. We want to do division first. So we're going to do 6 divided by 2, which is 3, and 3 times 3, which is 9. So 9 is the correct answer. The other answer that most people are probably getting is by taking 2 times 3 first, which would be 6, and 6 divided by 6, which would be 1. So the answers would either be 9 or 1, but 9 is the correct answer. Let's look at some other problems that use order of operations. So if we do order of operations, we know we want to do the parentheses first. So 1 minus negative 3. Minus a negative turns into plus. So that'll be 4 to the third power. Now we have to do exponents second. 4 to the third power is 4 times 4, which is 16. 16 times 4 is 64. Next, what we want to do is we are going to do multiplication. So negative 8. And I'm going to take 5 times 64. I'm going to use my calculator. And if I do that, I get 320. And then negative 8 plus 320 will give me 312. Again, don't be afraid to use that calculator to make sure that you get all the right numbers. Let's look at part B. First thing I'm going to do is I'm going to do my exponents. So I'm going to take negative 6. Or not my exponents, sorry, I said my exponents. I want to do my parentheses first. So 2 plus negative 1, which is 1. Next, I want to do my exponents. So 5 squared is 25. 1 to the fourth power is 1. Next, we do multiplication. And lastly, we do 25 minus 6, which is 19. So there's some more U practices, but we want you to try those out on your own. And if you, of course, if you need to see the answers, don't be afraid to ask Mr. Rakowski, and he can show you how to do those. All right, there's some other notes. A variable is a letter that is used to represent one or more numbers. Any number used to replace a variable is a value of the variable. Next, an expression involving variables is called an algebraic expression. So we're going to look at some algebraic expressions. In this algebraic expression, we're going to do this thing called evaluate. Evaluate means that we want to simplify as far as we can and get our answer as low or as simplified as we can. And we're going to evaluate it, and we're going to plug in x equals negative 3 into this problem. So negative 4, wherever I see up x, I'm going to plug in a negative 3. I like to do it in parentheses. 6 times negative 3 minus 5. So again, we got to do order of operations. So for order of operations, there's no parentheses. I can't simplify anything within the parentheses, but I can do my exponents. So negative 4, I know negative 3 times negative 3 is 9. I don't have any exponents over here, so I can't do that. Next, I'm going to do multiplication. So negative 4 times 9 is negative 36. 6 times negative 3 is negative 18 minus 5. Now I'm going to work from left to right. So negative 36 minus 18 gives me negative 54 minus 5, which is negative 52. 9. We're going to do the same thing on this evaluate. So x is equal to 2, so wherever I see an x, I'm going to plug in a 2. There's no parentheses to simplify, so I'm going to do my exponents. So 2 times 4 minus 3 times 2 minus 3. Next, I'm going to do multiplication. So this is 8 minus 6 minus 3. 8 minus 6 is 2. 2 minus 3 is negative 1. All right. We also have some more notes. So for example, if I have a problem like this where it is 3x squared plus 2x minus 8, we have some different terms. Terms are values that are separated by plus signs. So in this case, I could rewrite this problem so that I have all plus signs, so that this would be plus 2x plus a negative 8. So my terms in this case are going to be 3x squared, because there's and then separated by a plus sign, I have 2x. Separated by another plus sign, I have negative 8. So my terms in this case are 3x squared, 2x, and negative 8. A coefficient is the number that is in front of the power. So for example, my coefficient in this case is going to be 3's, 2's, and negative 8. So the number that precedes the variable. We have like terms. Like terms have the same variable and the same exponents. So like terms in this case, I don't have any like terms. My like terms are 3x squared, 2x, and negative 8, but none of them can be combined. We can combine like terms if we have them, but if you notice, 3x squared and 2x are not the same. They're not like terms because even though they have the same variable, they don't have the same exponents. Constant terms are the numbers that are all by themselves. So in this case, negative 8 is our only constant term. So let's go ahead and take a look at a problem that involves simplifying by combining like terms. First, we want to identify our like terms. Here's a like term, and here's a like term. We want to combine these, so 6 minus 7 gives us negative 1. We want to write the variables so that they are identical to these right here. Negative 12m cannot be simplified. Now, one thing we want to make sure is we want to simplify. This right here is not simplified because we don't usually want to write the 1. We just want to say negative m squared minus 12m. This is the best answer that we can come up with. For letter B, we want to find like terms. You'll notice that this has x and a y. You'll notice that this also has an x and a y. By the commutative property, we can rewrite this so it's 9xy. So these are like terms. If I combine them, I have 6 minus 9, which is negative 3, plus 13x plus 2y.